lesson you will solve quadratic equations by using the quadratic formula, and we'll also talk about the discriminant and how we can use that to determine how many solutions are for a quadratic equation. So this is the quadratic formula, and I have a song to help you remember how it goes, and it is to the tune of Pop Goes the Weasel. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll sing it one more time, and then we'll sing it together in class tomorrow. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So using quadratic formula, once you know an a, a b, and a c, you can plug anything in and solve. So this particular equation, if you remember how we solved by factoring, it'd be x squared minus 12x, and then I would add 20. So we would have to look for two factors of 20 that would give us a sum of negative 12. Well, this is a faster way to solve quadratic formula, and here's how we would do it. In this case, we would add 20 so that we set it equal to 0. So the first step is always going to be to set it equal to 0. And then we're going to identify our a, our b, and our c. So a is 1, that's what's in front of the x squared. B is negative 12, c is 20. And then we use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So as you see what I did when I sang the song, I plugged in the values. So here's my negative b, so we can simplify that into just being positive 12, plus or minus the square root of, this is 144, minus, there are no other negative terms here, so we're going to subtract all of this, which would be 80, all over 2. Now we can do some simplifying. So we have 144 minus 80 is going to be 64. So it's 12 plus or minus radical 64 over 20. And now when you find, or over 2, excuse me, when you find the square root, you're going to be able to have two separate cases. So this is going to be 12 plus 8, all divided by 2, and 12 minus 8, all divided by 2. That's where the plus or minus comes in. So then you have 20 divided by 2, which would be 10, and 12 minus 8 is 4 over 2, which is 2. So my solutions are 2 and 10. So this is a really nice example of quadratic equation or quadratic formula and how it works to solve, because it works out nice and whole. We will have some examples where it doesn't. So let's try another. Step 1 is to set it equal to 0, and this one is. A is 3, B is 5, C is negative 12. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So I plugged in the values as I sang the song. We have negative 5 plus or minus, this is going to be 25. And now you see these minuses, I have two negatives, so that's going to be a plus situation. 12 times 12, which is 144, all over 6. Now I can do a little simplifying. Negative 5 plus or minus 144 plus 25 is 169, all over 6. This is a perfect square, so it's going to be negative 5 plus 13 all over 6, and negative 5 minus 13 all over 6. So this is going to be, let's see here, 8 over 6, which is going to simplify into 4/3. And then this is negative 18 over 6, which would simplify into negative 3. And you could also use a decimal equivalency too. Now you can always check by graphing and seeing what the roots are, but you try the examples of quadratic formula in your notes and make sure you're identifying your A, B, and C first and taking your time and working slowly. All right, so the 4 ways that you can solve for roots is graphing, factoring, completing the square, and quadratic formula. You've been taught all 4 now. So you choose the best method. When you are going to solve, you always have to set it equal to 0 first. So for this particular example, you could actually choose any of those 4 to solve this. It's really your personal preference what you would like to do. Obviously today I want you to practice the quadratic formula, but you can choose any method to solve when you're looking for roots. Let's talk about the discriminant. The discriminant is what is underneath the radical sign. It's b squared minus 4ac. And this will tell you how many solutions a quadratic equation has. So here my a is 2. This says 2x squared plus x plus 3. I don't know if you can see that very clearly on the video. So my a is 2, my b is 1, and my c is 3. So I do just b squared minus 4ac. And you'll notice I have 1 minus, because that's just 1 minus, 24. So that gives me negative 23. Well, since this is a negative discriminant, I know that I'm going to have no solutions. I know that I'm not going to have any roots. So checking the discriminant first can really help save you a lot of work, because you would, if you did quadratic formula on this, you would get to something that doesn't work. It would be like 4 equals 2 or something, and then you know, hey, that's an empty set. What about this equation? It's x squared plus 6x plus 9. My a is 1, my b is 6, my c is 9. So I have b squared, so that's 6 squared, minus 4 times a times c. So this is 36 minus 36. That's 0. So this tells me there is 1 root. So I know for sure I can simplify this down and I'll have 1 solution. How about positive here? This is x squared minus 5x plus 2. So a is 1, b is negative 5, c is 2. So it's negative 5 squared minus 4 times 1 times 2. So that would be 25 minus 8. That'd be 17. So I know this has 2 roots or 2 solutions, just like the ones that we did a little bit ago. It's going to be 2 solutions. So checking the discriminant can really help you see what you're going to have. So let's try an example of that together, and then I'll have you do one in your notes. I want to use the discriminant, so I'm going to have to set it equal to 0 first. So I have 4x squared plus 5x plus 3 equals 0. Now I identify my a is 4, my b is 5, my c is 3, and I have b squared, so 5 squared, minus 4 times a times c. So this is 25 minus, this is 1648. When you subtract, you know you're going to get something negative. And you don't really have to have the actual value out, but it's good to go ahead and figure out what that is. So I would say this is negative 23, and I know that this is no roots or a no solution because it's a negative discriminant. So try the example in your notes of checking a discriminant to see how many roots it has. Okay, we're good.